Something big just dropped, and it's not another transformer upgrade. It's something completely different. Liquid AI. A Boston startup spun out of MIT just revealed Hyena Edge on April 25th, right before ICLR 2025 kicks off in Singapore. And yeah, Hyena like the animal that laughs at lions, except this thing is laughing at latency graphs on your phone. It's built to run powerful AI right on your device, faster and lighter than anything we're used to, and it might just be the first real sign that the transformer era is starting to crack. So let's rewind just a bit. For years we've been in this romance with the transformer architecture because of that paralyzable attention mechanism Baswani and friends introduced back in 2017. It's gotten us some wild breakthroughs, sure, but there's a big catch. Squeezing these chunky transformer models onto a smartphone without frying your battery or devouring your RAM has been painful. Most edge-optimized models like SMLM2, like FI, even Meta's Llama 3.21b, still lug around standard attention blocks and rely on kernels that are great on a data center-grade GPU, but not so hot on the Snapdragon inside your pocket. So Liquid AI is basically saying, why not ditch most of that attention baggage and, do something leaner? Enter Hyena Edge, a convolution-based multi-hybrid model. Convolutions on a language model, yep. Convos aren't new, they totally rule in vision, but here they're part of this broader family of operators called Hyena, which Michael Polly's group kicked off a couple years ago. The Edge variant takes it further by replacing roughly 2/3 of the grouped query attention operations inside a top-shelf transformer plus backbone with these gated convolutions from the Hyena subfamily. That swap alone, honestly, cuts a heap of memory overhead and avoids the quadratic time blow-up that attention brings. Now, Liquid AI didn't just eyeball some abstract benchmarks on a desktop GPU and declare victory. They ran the whole thing on an actual Samsung Galaxy S24 Ultra. Yes, the phone you might have in your pocket right now, and compared it to a parameter-matched GQA transformer plus model prefill latency, Hyena Edge was faster across the board, and at longer contexts, we're talking up to 30% quicker. So the code latency, it's kind of the same story. Once you go above 256 tokens, that convolution magic really kicks in. And yeah, memory usage was actually lower at every sequence length they measured. Which is honestly huge when your app's data has to squeeze in between Spotify, TikTok, and, the photo album of your cat. But what about accuracy though? Because let's be honest, nobody really cares if a model is lightning fast if it can't even finish your sentence. So Liquid AI trained both models on the exact same 100 billion tokens, and then unleashed them on a whole battery of standard language model benchmarks. On Wikitext, Hyena's perplexity dropped to 16.2 compared to 17.3 from the transformer baseline. Lambda went from 10.8 down to 9.4. On PQA, the accuracy nudged up from 71.1 to 72.3. Hellaswag saw a jump from 49.3 to 52.8. Wino Grande climbed from 51.4 to 54.8. ARC Easy crept up from 63.2 to 64.4, and ARC Challenge pushed from 53.34 to 55.2. Oh, and here's a funny footnote. Both models actually tied on a Pika variant at 31.7. So the Hyena didn't win absolutely everything, but it never fell behind either. So the net result? Speed and memory savings come with equal or better predictive oomph, which is honestly the holy grail for on-decision AI. Okay, but how did they actually arrive at that architecture? This is where it gets super nerdy but also kind of sci-fi cool. Back in December 2024, Liquid AI unveiled something called STAR, the synthesis of tailored architectures framework. Picture an evolutionary algorithm wearing a lab coat. You feed it a bunch of primitive operators, some constraints about latency and memory, sprinkle in linear systems theory, and then let it evolve architectures generation after generation. So, for Hyena Edge, they actually kicked things off with a population of 16 candidate models, evolving over 24 generations. STAR, juggled like 18 different convolution options, Hyena Full, Hyena X, Hyena Y, with filter lengths ranging anywhere from 3 to 128. Plus, there were several flavors of grouped query attention and swag glue feed forward layers in the mix. Every candidate got its latent memory and latency profiled right on the actual S24 Ultra, not just some random desktop card. Oh, and get this, they even trained each mini model for 5 billion tokens just to keep score on perplexity in real time. As those evolutionary cycles rolled on, the Hyena Y operator just kept muscling its way to the front of the pack. Turns out, this variant really strikes that sweet balance. Plenty of expressive power, but without the inner convolution overhead you see in Hyena Full, and it's just lighter overall. With a different gating setup than Hyena X, STAR could literally visualize how many self-attention, Hyena, and swig-glue blocks were inside each generation. If you check out the walkthrough video Liquid AI posted, you'll actually see those histograms shifting over time. So, self-attention bars were shrinking, the Hyena Y bar was swelling, and latency curves were dipping. Kind of like watching natural selection, but with code blocks instead of genes. By the final generation, STAR spat out the design that became Hyena Edge, 32 layers deep, width 48, attention head size 64, and 2/3 of what used to be GQA replaced by Hyena-gated convolutions. No hand-tuning, no trust me bro, just hardcore automated search. And yeah, they stress-tested the outcome directly on the phone again, just to be sure those earlier approximations held true at full scale, which, honestly, they did. Otherwise, we wouldn't be talking about this. One angle I love is how they benchmark responsiveness on short prompts, because that's where hybrids usually fall flat. Edge apps like voice assistants often fire off queries under 20 tokens, so shaving milliseconds there is everything. Liquid AI reports their prefill latency advantage is visible right from the shortest sequences. That's basically the model's first impression for the user, and it only widens as you feed in longer context. Even if you're just sending a single sentence to your on-device language model, Hyena Edge can answer faster than its transformer twin. Now, just a quick side tour. Group QA attention. KI was already an optimization to make transformers more manageable by letting multiple queries share key value heads. It's lighter than full attention, but still, at its core, it's attention. Hyena Edge, swaps most of those heads out entirely, and that's what really slices the quadratic term down. Convolution operations, they scale linearly with sequence length, so for 512 or 1024 tokens, you're looking at some serious compute savings. The kicker is that Liquid AI engineered their gated convolution, so they still capture long-range dependencies. Something older convolutions, honestly, struggled with. All that said, Liquid AI isn't keeping this in a vault. They've already stated loudly that they plan to open source Hyena Edge and a series of Liquid Foundation models in the coming months. If you're like me, that sentence feels like Christmas morning. It means developers will get a turnkey model that can run natively on stuff like the S24 Ultra, maybe the iPhone 16 Pro, maybe even a Raspberry Pi if you dare, without requiring a cloud subscription or a 5-watt charger. And because it's open, we'll see 1,000 forks. Someone will quantize it to 4-bit, someone else will fine-tune for coding assistance, another team will port it to watch OS. Mark my words. More broadly, this is part of a bigger trend. We're stepping into a post-transformer world, or at least a polyarchitecture ecosystem. Transformers are still unbeatable for heavy GPU jobs, though. But when it comes to edge devices where, every bit of energy really matters, hybrids like convolutions, recurrent models, and even state space models are finally getting their moment. And with smart tools like STAR doing the architecture search, we're moving faster than manual tweaking ever allowed, honestly. But the best part? Everything's tested directly on real devices like smartphones, not just on GPUs in a lab. So what works in theory also works right in your hand. Zooming out a little, phones now have powerful NPUs, laptops are shipping with like crazy AI accelerators, and there's a lot of pressure to keep AI local for privacy. Models that can crush benchmarks like Lombata at a perplexity of 9.4, use less RAM, and respond 30% faster, could be exactly what tips the scale. Running everything on devices just feels better. No lag, no cloud dependency, and no leaking personal data when you're offline. Credit where it's due, the team behind this, listed under Liquid Science, includes Armand Thomas Stefano Massaroli, Michael Pulley, and the rest of Liquid Edge. They built on the Hyena X and Hyena Y work, plus tweaks like Swiglu and, of course, the original Transformer ideas. It's less about one-off brilliance and more about letting algorithms evolve designs that are actually smarter than we could ever create by hand. Oh, and just a quick note. Early versions of Hyena Edge were tested at a width of 512 before they scaled up to 48 for the final model. They kept the attention head size at 64. During the STAR's evolution runs, they estimated whole model latency and memory by just adding up pre-measured operator stats, which honestly let them move fast without wasting full training cycles. They even visualized it. Watching those models slide toward the bottom left corner, where low latency meets low perplexity, was honestly like watching a stock ticker, only way cooler. So where are we headed? If the last few years belong to transformers, the next could honestly be ruled by automated architecture search, hybrid models, and real practical edge AI. Hyena Edge proves you can rip out most of the attention, still match or beat quality, and get way faster on real-world devices. And since Liquid AI plans to open source it, they're inviting everyone to take it even further. Is this the future? Powerful AI running straight from your pocket with no cloud in sight, or are we just dreaming too big, too soon? Thanks for watching, and I'll catch you in the next one.